Okay, I'm going to run through a couple demos real quick. One is going to be based on the live session that I did last week, doing the demo of the gripper for a single pin. This is not one of the one of the design projects that you're going to be working on, but it's one that can give you some ideas. And then I also wanted to go through the um, uh, drawing and assembly drawing and detail drawing process for this. So I'll probably break it up into 2 or 3 demos, but let's go ahead and get started with the first one. So I want to go through again the making the gripper for a single pin. So I've already started Fusion. I've saved my file. Remember, that's a good thing to do right away so that it starts the automatic saving feature. So I've saved my file, and now I want to go and I want to create the pin drawing. So let's go ahead and we'll start a new component, and I'm going to call this component pin. Okay, and then let's draw it like this. This is a pretty simple part to make. The diameter on this is 15, although some people did have legitimate questions about it. You know, there's some of the dimensions that maybe, or some of the features may be a little bit difficult to put together. But I'll show you how. And actually, that's not a huge concern. I'll show you. So let's extrude this, and we'll go up 28. Okay, and then I want to go ahead and get the neck in there. And this is where the confusion was. So I'll show you how you can easily get around that. So I'll draw the neck right there, and that has a diameter of, you know, if you let me back out here. Let me bring this around. So look, if you take the 3 millimeter shoulder radius and subtract that twice, right, on both sides, 3 and 3, from 15. So 15 minus 3 minus 3, that's 15 minus 6 is 9. So you can make that diameter right there 9. In fact, it actually comes out more like 10 on my actual drawing, because what I did here on these dimensions is I rounded, because it's not very critical whatsoever. So if some of you were following this and then you got like, hey, this can't be 3, it's not a big deal. But so let's go ahead and do that. So I'm going to do 9 millimeters right there, and then I'll finish my sketch. And then I'm going to extrude this. And the key here is I'm going to extrude it up longer than I know I need it, because I'm going to join it with the sphere, right? So if you just extrude it up the distance here, 3 millimeters, you're going to be in trouble, maybe. So with the geometry. So I'm going to do that. We'll join that. And now I want to do the sphere. And the sphere, it's kind of interesting. I find that it's easier to draw the sphere at the origin down here and then move it up. You know, I suppose there's probably smarter people than me that could figure out an easier way to do this, but sometimes I just go for the brute force method. So I'll draw a sphere. I'm going to put it right at the corner, right here and right there, and it has a diameter of 15, right? And whoops, what did I do? I joined it, or I subtracted it. So let's go back to edit feature. I did this once before, and let's just make it a new body, okay? So that means it's separate, right? And so we can move it. We need to actually do that. So I'll go over here to bodies, expand that. There's body 2, right? You can see what that is. That's body 2. So I'm going to go right click and say move, and I'm just going to move it up. And here we can go, well, we can do it this way. We can go up like this, and you see we got the readout here. So I'm going to type in 36. Boom, boom. Now, we're not done yet because we have two bodies. We can't have a component with two bodies here. So we want to combine these two. So we go to combine, and we just pick this, and we just pick this, and we don't need to keep our, we don't need to make a new component. It already is a component. We don't need to keep the tool, so we're just going to say join, and there we go. Okay. Last thing, we want to round this with a radius of 3, and then there we go. Okay, so now we have our pin completed. And now we can move on to our gripper. Okay, and again, this is just kind of a rehash. I'm kind of going a little bit fast, but you guys know that if you have questions, you can email me. I can even do another live session. But let's go ahead and get our the gripper in there, or the body, I should say. And I'm going to make things easy on myself. I'm going to orient this like so, and I might just move it up a little bit. It's down here. That's not very convenient. So I'm just going to move it up, and it doesn't matter how much you move it up. We can go up like this. That's fine. Actually, maybe we could kill two birds with one stone. So I have that up there. And we'll say okay, and then we got the gripper in here, or the body. Okay. Now I do want to make a shout out to a couple of students. I won't mention you by name, but a couple of you have been doing a lot of the Fusion, the Learning Academy or Academy courses, and I think that's really awesome. I can. You go through enough of those, and I can tell that it's really going to help to develop your skill set with Fusion. But not only Fusion, remember that SolidWorks, Pro-E, and all the other parametric modeling software is all based on the same kind of idea. So it's kind of like a universal language. So I think that's really good. And please, if you get those done, please send me the certificates that you earned. All right, so let's move on to this. So I'm going to keep it right about there. I think that looks good. If I need to tweak it up or down, then I can. So the way I get started with this, we're going to make a gripper fingers to grab the one pin, okay? And I want to try to model the shape that I have on the head of the pin here. So I'm going to create a new component, all right? And I'm going to call this the finger dash, let's see, I'm going to do the left one first, so I'll do finger dash L. Remember, you can always rename these, so this is not a super big deal. Look at what I did. See, I've already, now some of you, I could say that I've done this on purpose, but I haven't. Let's see what I've done here. Now this is going to make problems for the drawing phase, for the assembly drawing specifically. All right, so if you look at what I have here, let me minimize this. I've inserted the Schunk gripper body, and I've started the new component for the finger, but I wasn't paying attention, and I wasn't in the highest order right there, okay? That's the assembly. So what I've done is, by inadvertently dropping these in when pin was highlighted right here, I've made these the sub-assemblies under pin. Now, that's not gonna be a problem with our model, all right? You won't even notice, really. But where it will be a problem is when we do the drawings. And so what I'm going to do to fix this, I'm going to go up here and I'm going to activate that component. And then I'm going to drag finger, and I'm going to drag it into the highest level assembly. And you see how it slid it back? I'm going to do the same thing for the Schunk. Okay, right there. All right. So that's going to save you a lot of pain later on down the road. Now, we want to go back to building the finger, and so in this case, I want to activate this component. That way, I'm building that. Okay, and what I want to do is I'm drawing the left, so I'm going to this is where it has to be attached. So I'm going to base it on this. So I'm going to sketch on this surface right there. Okay. And I'm kind of looking a little bit beyond it right here. So I'm going to go to slice and kind of slice open. So now I'm looking at the face that I'm going to, and I thought about this a little bit more after I did the first demo. So what I'm going to do is I'm going to draw, or excuse me, I'm going to project this surface right there. So I pick that surface, I say okay, and what that does is it brings in those edges so that I can use that geometry in the current sketch that I'm making for the finger left. Okay, but now I'm going to go a little bit different here. And maybe this will give you some ideas, because one of the things that I've found when I'm using this, and I use this gripper with the robotics class. Hint, hint, if you want to take a robotics programming class while you're still going through before you transfer AET 110, the robotics class is offered in the fall. That's a good class to take for engineers, mechanical engineers, manufacturing engineers, any engineers really. There's a little bit of, not a little bit, there's a lot of programming. We use the language Carol, but if you pass the class, you also get a Fanuc certification for robot handling, and that's a good thing to have on your resume. Plus, we have another class after that, robotic vision, which is another certificate that you can get. Okay, so anyway. So I have this geometry, and let me just show you. I'm gonna hide the Schunk, and aha. So that's what I want right there. And in fact, I'm going to base this. I'm gonna pick that right there, and I'm gonna draw down. Now, how far do I need to draw? Well, I'm going to. Actually, you know what? I'm going to back out here for a second, because what I want to do is I also want to yeah. All right, hold on. Time out here for a sec. Okay, sorry about that. I had to take a time out for a second while I figured out what was going on. Okay, so what I'd also like to do before I move on is do a projection of the pin. Now notice the pin is not there. And you look over here and hey, it's not frozen. It's visible, so where the heck is it? Ah, look at that. I've done a slice. So let me unslice it, and there we go. And now just to help myself, I'm going to do a projection of all the business there. And in fact, I could do bodies and do that right there. Right, and then there we go. And now I can go back to slice because I'd really like to work in that. All right, and now let's get back going here. So I'll freeze that, and let's go, and I'm going to grab like halfway down the neck. Okay, I think that's going to give me a good amount of grip. Maybe I should go down all the way, but I can figure that out. All right, so now let's get some of the constraints. I want to do a collinear constraint between this edge and this edge right there. Oh, and it's not gonna let me do that. Let's see if I can. There we go. Okay. So collinear constraint, and I want to do a let's do another collinear constraint. Let's see if I can get it. No, not right there. Let's do this. Let's dimension. I want to know that the distance is between here and here, and that's 41. Okay. And that's a reference because that's not part of the geometry right now. So I'm going to make this distance, actually, and let's get, what is this distance from here to here? It's just good things to know. 11.9, again, that's reference because those are projected lines, so that's not geometry I can change. So I want to move this down. Let's draw a line from here to here. And I'm going to click on that line that I just drew and make it a construction line. That way I don't have to worry about the geometry. And now I can do a collinear between this and this. There we go. All right, so now I'm coming right down there. Everything looks good. It's all black. But I like this. This is what I thought of. I'm going to expand this a little bit. And what I'm going to do is I don't want it to interfere with the gripper up top. So what I'm going to do is I'm going to expand the sides left and right, and I'm going to make a little shoulder, and that's going to help with the alignment of the gripper fingers. Because one of the things that I found in using this is that the gripper fingers, because they're only being held by a single fastener right here, screw, they can pivot around that center point because they don't have 2 points to hold them in line. And so you can end up through, normal usage having these fingers be not vertical or not aligned in line with the gripper body and the robot. So, and that's a problem when you're dealing with accuracy like we are with the industrial robot. So what I thought of doing is I'm going to project off of this point right there and come down a little bit and go down like this, like so. All right, and I want to, let's see, how much am I gonna offset it right there? So that looks like 2 millimeters, which is a pretty, let's go with 3 millimeters. So it's a little bit beefy. Let's make sure that this is parallel with this. I think that's going to be redundant. Yeah, it is. And we want to make sure that this line is even with that, and it is. And now I want to do the same thing on the other side. So I'll just draw a line over here. We'll come over 3. We'll go down like this, and we'll come in like that. Right? And then let's dimension that. Make that 3. Actually, what we should do is we should make this equal to that one, D11. That way they're symmetrical. We want to make this collinear. I want to make that collinear with that. Right, and I think everything else is good. It's all black. Now I'm going to leave it with the groove. You'll see, and then we can finish that sketch. Okay, and let's turn this back on, and we can turn off the pin. I don't think we need to see that. And so you see what we have here. Now, I want to make this gripper, it's going to be half the width. Remember that the jaws right here are in the closed position. So in this position, the gripper fingers that I'm designing should just touch. So I want to get the distance from here to here, and that's 16 millimeters. So I want to make my gripper fingers no more than 8 millimeters apart. In fact, just a smidgen less, maybe a half a millimeter less, would be good, so that we don't have any problems with that. So here's what I'm going to do. I'm going to extrude this. So let's extrude that and that, and I want to get that too. And we're going to get the side flanges here, right? And I'm going to extrude it out. Let's say that there's a 0.5 millimeter gap between the two. So that means I want this one to be 8 millimeters minus 1/4 of a millimeter, so 7.75. And the other one will be 7.75, and that'll give me a 0.5 millimeter gap in there. So 7.75. This is going to be a new body, and we go just like that. Okay, so there's one of the gripper fingers. Now I'm not done with it yet, because what I want to do is this is what I thought of. Let's go ahead and activate that sketch again. So there it is. Because what I want to do is I want to extrude these wings, in essence, back. Maybe we'll go 2 millimeters, right? Or maybe 3 millimeters. Yeah, maybe 2 millimeters. We'll go minus 2 millimeters. All right. And so what that's going to do is that's going to give me a kind of a positive position where I can't, the gripper finger can't rotate in that single point fastening that it's designed with. So I think that's a really good idea. You know, I could even build up the bottom a little bit here too, but you know, I don't need to worry about that right now. And so there we go. All right, so now we're not done yet, because we have to get it so that it's going to grab the body. And the idea with this project is that we know what kind of pins or devices, things, parts that we're going to be picking up. And this is very common in the industrial world. You know what the robot is going to be picking up. It's not picking up anything and everything. So let's go ahead and turn the pin back on. Now here's where we want to basically cut out the shape of the pin in our finger right here. So we can go up here to combine, right? It doesn't seem like we want to do the combine, but watch, we go combine, and what we want to do is we want to do a cut, okay? And so we want to keep our tools, right? Because we don't want to cut it and have the pin disappear, right? That would be that's the tool. So I'm going to pick the target body, and then the tool body is going to be the pin. Okay, I'm keeping the tool, and then I'm going to say okay. And now, and let me hide the pin, and now you can see what I've done. I've made a tool or pin shaped cutout right in there. Now, there's this is exactly the size of the pin. And again, we want to build in some kind of tolerance, some kind of allowable, acceptable error in that. So what we can do here is we can go up to offset face, right? So these are all faces. So what I'm going to do is I'm going to offset this face, and I'm just going to push it back or push it in slightly. So it doesn't have to be a lot. Maybe, you know, a half millimeter, 0.5. Whoops, I went the wrong way. Minus 0.5. Yep, we want it to get a little bit bigger. This is a negative feature, so we want it to get a little bit bigger. And then there we go. All right, so that was easy, right? And if we put the pin back on, now you can see there's a little gap in there, which just gives us a little bit of tolerance. You know, maybe the gripper finger isn't going to be made exactly properly. Maybe the pin is not made exactly properly. Maybe, you know, that we're off a little bit in our movement of the robot. So this gives us a little bit of leeway there. So it's a good design thing to do that. So let's look and see what we have. So now, are we done with the gripper finger? No, because I think it would be, I'm going to hide the thing too. I think it would also be good to do a little design intervention here. So it's just good practice to have on the mating surface to relieve this edge. All right. And again, that's just the tolerance thing, you know. It's just in case things go a little bit awry. So I'm going to chamfer this edge, and it's going to be a real, actually, you know what, let me turn on the gripper here real quick. Yeah, okay. So there's a couple things I'm going to do first. Actually, before we do that, I'm going to put a fillet right in there. Now, rounds are very, very necessary in design and manufacturing. Sharp edges are a big no-no, they are, let's make this 1 millimeter. Let's see what one, yeah, that looks good. Sharp edges are stress concentrators, so we want to stay away from those. So we'll just round that right there. That looks good. And now I'm going to go ahead back and do the chamfer on this. So let's do our chamfering. So I'm going to relieve this edge right here first, and that edge right there. And let's see what a 1 millimeter. I like to put it in there and kind of look at it and see. I think 1 millimeter is probably pretty good. We could probably, maybe we could go to 0.5 millimeters. Yeah, just a smidge, just a very small relief there. And then we can do the same thing here. Right click, repeat chamfer, and let's do this edge all around here. Okay, and I'm going to relieve that edge right in there too, and I'm going to also relieve this edge in there, and I'm going to do this at 0.5 again. Right, so it just gives me a little bit of it's a good design thing to do. Just gives me a little bit of error acceptability. And now the back surface over here, we don't need to chamfer it, I just want to round it. So so let's turn the Schunk on so we can kind of see where everything goes. I want to keep this edge right in there sharp, right? Because that's going to be a mating edge with the jaw. So everywhere else though, I can round that. So let's go to here and round that over there and round that over there. So we'll do a 1. There we go. So that looks good. And let's do this over here. All right, you get the idea. All right, I don't need to belabor this point, but it's a good thing. It's a good design thing to have in there. In fact, right there, that probably should have done this first. So remember, we can do that. So if we go back here, look, there's the chamfer. So watch, if I go back to this, I could move this back. Let's see if I can. All right, we can move that. Let's see if I can move that chamfer forward. Yeah, I'm not going to worry about it. So you can move these. All right, I'm afraid that I'm going to mess it up and just delay this longer. So, all right, so there's my design. I'm pretty happy with that. We're not quite done with it yet. We still need to thread this. This is threaded, so we'll go to thread, and we'll pick that hole. It's an M4 thread, so it identified it right there. And there's our finger. So that's the finger left. Now, we want to create another finger. So now, when you do this, we need to go up a level to the assembly level. So activate that, and I'm going to go to create mirror, and actually I need, my mirror is going to be the origin. So let's go to mirror, and I want to pick this object. So I'm going to come over here. Now, if you do it this way, let me just tell you, notice that I'm picking faces because this says pattern type faces. That's what it's looking for. I could change it here to component, right? Or I could just pick the component over here. So we can, whoops. It's not going to do that. So let's go to component. We pick that right there. Okay. And then my mirror plane is going to be this plane right there, right? That's bisecting. It's not this surface, because remember this surface is offset by 1/4 of a millimeter. So it should be this one right here. And when we say OK, it should make a finger L mirror. So I'm going to rename this right now, finger R for right. And let's inspect this and make sure there's a gap. And sure enough, there's a gap. So that's good. That's what we designed. And look how easy that is. So we really just need to do one. If we turn our Schunk back on, then we got that. Everything's good to go. Last thing I'm going to do is get in that fastener. Let me go ahead and measure this because I need to know the length here. So from this surface right here to this surface right here is 13.759 millimeters. So, 13.75 millimeters. That's going to help me determine which fastener to get. So I'm going to go up to, I'm at the higher level still, okay, because I'm going to drop this in, so I need to be at the higher level. This is going to be a new component, and let's go here, fastener, metric. We want a socket head, and it's an M4, and let's just pick that. And what is the length? It was 13.75, so 14 is too long. Let's go with 12. All right, so 12, we go to product detail, and then we scroll down to 3D SolidWorks, but we don't. We do a step, and we step file, and then we say save. And then that brings it in right there. I'm going to leave it right there because it really doesn't matter. And I'll say OK. Right, and there it is. Now, I'm going to go ahead and rename this. And this is going to be my M4 by 0.7 socket head cap screw. All right, there we go. And then let's go ahead and get this into position. So we'll use a joint. And I'm going to pick that face. And I picked the circle, so it automatically identifies the center of that. And that's on that face. So I'm going to pick it right there so that the centers will align. And then there we go. And you can see that's backwards. Hello. So you just use the flip right there. Flip. Here we go. All good. Motion. Rigid. Yep. We say OK. All right. And now we just want to get the other side. But now that we've got this in the position, this is really cake because we want to mirror it. So we can go to mirror. I suppose you could insert this and then mirror both of them together, but it's not a big deal. We want to do that. The mirror plane is going to be this plane again, right there. And we say OK. And there it is right there. And that's it. Okay. So I've designed what I've called the gripper 0, right? It's just the gripper fingers with for a single pin. We've got some alignment wings in there. Last thing, let's go ahead and do the physical material. These are going to be made out of plastic, right? So I talked about how we're just going to 3D print these. So I'll do ABS plastic. And then I can drag it over there, and I can drag it over there. And actually the pin is also, no, the pin is actually wood, but that doesn't matter. The pin's not going to be in any drawings or the assembly. So we can go like that. And then last thing, appearance, I don't want white. I'm going to do a plastic and translucent, and maybe green. Green is good, or yellow, depending on which way you want to go. Let's go with green. I always do. Whoops, that's not what I wanted. Let's try that again. All right, so we'll go to green here. We'll go to green here. All right, so now we have some green plastic. and we're good to go. All right. So when we pick up again, what I'll do is I'll go through the drawing phases of this. All right. Thanks. Talk to you soon. Bye.